Outdoor-rated ground fault circuit interrupter receptacles exist with covers that are weather-resistant. They can operate without an equipment grounding conductor when used with the Underwriters Laboratories listed adapter with a green indicator light that verifies proper grounding. The cost to replace an outdoor outlet with a ground fault circuit interrupter receptacle typically ranges from $75 to $150 per outlet. This includes materials, labor, and any necessary permits. To determine the number of ground fault circuit interrupter outlets required, you will need to identify the circuits that feed the outdoor outlets. It is likely that some outlets are downstream of others, but it is essential to verify this by disconnecting wires one at a time to ensure proper protection. Ground fault circuit interrupter outlets are required in outdoor locations to protect against electrical shock accidents. By installing ground fault circuit interrupter outlets, you can minimize the risk of electrocution and ensure the safety of tenants. Present the homeowner with information about the importance of ground fault circuit interrupter protection and the estimated cost of the upgrade. Emphasize the safety benefits and the potential cost savings in the long run by avoiding electrical accident. Firstly, let's dive deeper into the technical aspects of ground fault circuit interrupters, or GFCIs, especially concerning their application in outdoor settings. These devices are designed to protect individuals from electrical shock by monitoring the balance of current flowing into and out of a circuit. If there is an imbalance, even a tiny one, it indicates that current is leaking somewhere, potentially through a person. The GFCI quickly trips, cutting off the power and preventing a dangerous shock. Now, regarding their operation without an equipment grounding conductor, or EG, it's a bit of a nuanced topic. In modern electrical systems, the EG, often referred to as the ground wire, provides a path for fault current to flow back to the source, allowing overcurrent protection devices like circuit breakers to trip and clear the fault. However, in older homes or in specific situations where an EGC is not present, GFCIs can still provide a significant level of protection. When a GFCI is used in a non-grounded circuit, it operates differently. Instead of relying on the EGC to trip the breaker, it directly detects the current imbalance. This is why the use of Underwriters Laboratories listed adapter with a green indicator light is crucial. This adapter helps ensure that the GFCI is properly connected and functioning as intended in the absence of a traditional ground wire. It's important to note that while a GFCI can protect against electrical shock in a non-grounded circuit, it doesn't provide the same level of protection as a fully grounded system. A grounded system offers additional protection against surges and other electrical disturbances. Secondly, let's break down the cost factors involved in replacing outdoor outlets with ground fault circuit interrupter receptacles. The estimated range of $75 to $150 per outlet takes into account several variables. The cost of the GFCI receptacle itself is a primary factor. Outdoor-rated GFCIs, which are designed to withstand the elements, tend to be more expensive than standard indoor receptacles. Labor costs can vary depending on the electrician's hourly rate and the complexity of the installation. If the existing wiring is in poor condition or requires modifications, the labor costs may increase. Permit fees are another consideration. Depending on local regulations, a permit may be required for electrical work, and the cost of the permit will be added to the overall expense. Additionally, the cost may increase if the electrician needs to install new weatherproof boxes or covers to ensure the outlets are properly protected from the elements. Thirdly, accurately determining the number of ground fault circuit interrupter outlets needed is critical for ensuring comprehensive protection. While it might seem straightforward to simply replace all outdoor outlets with GFCIs, it's often more efficient and cost-effective to identify the circuits that feed those outlets. If multiple outlets are in the same circuit, only the first outlet in the series needs to be a GFCI receptacle. This is because a GFCI protects all downstream outlets on the same circuit. To determine the circuit configuration, you'll need to disconnect the wires from the outlets one at a time and use a circuit tester to identify which outlets are on the same circuit. This process requires caution and should only be performed by a qualified electrician. Once you've identified the circuit configuration, you can strategically install GFCIs at the beginning of each circuit to protect all the outlets. Fourthly, the importance of ground fault circuit interrupter protection in outdoor locations cannot be overstated. Outdoor environments are inherently more susceptible to moisture, which significantly increases the risk of electrical shock. Water can create a conductive path between electrical components and a person, allowing current to flow through the body. This can result in serious injury or even death. Ground fault circuit interrupter outlets are specifically designed to detect these dangerous current leaks and quickly cut off the power, preventing a shock. They are an essential safety measure for protecting anyone who might come into contact with the electrical outlets or equipment in an outdoor setting. Fifthly, when approaching the homeowner about the need for ground fault circuit interrupter protection, it's helpful to present a clear and compelling case. Start by explaining the importance of electrical safety and the potential risks associated with non-ground fault circuit interrupter outlets in outdoor locations. Provide information about the function of GFCIs and how they protect against electrical shock. Present the estimated cost of the upgrade and emphasize the long-term benefits of investing in safety. Highlight the potential cost savings that can be realized by avoiding electrical accidents, which can result in costly medical bills and property damage. By presenting a well-reasoned argument and emphasizing the safety benefits, you can increase the likelihood that the homeowner will be receptive to making this important upgrade. Sixthly, let us consider the National Electrical Code, or NEC, requirements for ground fault circuit interrupter protection in dwelling units. The NEC is a widely adopted standard for safe electrical installations, and it provides specific guidelines for when and where GFCIs are required. According to NEC Section 210.8, ground fault circuit interrupter protection is required for 125-volt, 15 and 20 amp receptacles installed in various locations, including bathrooms, garages, and outdoor areas. This requirement is in place to minimize the risk of electrical shock in areas where moisture is likely to be present. It's important to consult the latest edition of the NEC to ensure compliance with all applicable requirements. Understanding these requirements can help you effectively communicate the importance of GFCI protection to the homeowner. Seventhly, let's discuss the different types of ground fault circuit interrupters available and their suitability for outdoor use. While all GFCIs perform the same basic function of detecting current imbalances, they come in different form factors and with different features. Receptacle-type GFCIs are designed to replace standard electrical outlets and provide GFCI protection at the point of use. Circuit breaker-type GFCIs are installed in the electrical panel and protect an entire circuit. Portable GFCIs are designed to be plugged into existing outlets and provide GFCI protection for temporary applications. For outdoor use, receptacle-type GFCIs with weather-resistant covers are the most common choice. These devices are designed to withstand the elements and provide reliable protection in wet or damp environments. It's important to choose a GFCI that is specifically rated for outdoor use to ensure its durability and performance. Eighthly, let's examine the process of installing a ground fault circuit interrupter receptacle in an existing outlet box. Before beginning any electrical work, it's crucial to turn off the power to the circuit at the breaker panel. Then carefully remove the existing outlet from the box and disconnect the wires. Identify the line wires which carry power from the source and the load wires which carry power to downstream outlets. Connect the line wires to the line terminals and the GFCI receptacle and the load wires to the load terminals. Ensure that all connections are secure and that the wires are properly insulated. Finally, carefully tuck the wires into the box and secure the GFCI receptacle in place. It's important to follow all manufacturers' instructions and local electrical codes when installing a GFCI receptacle. Ninthly, let's delve into some common misconceptions about ground fault circuit interrupters. One common misconception is that GFCIs are only needed in areas where there is water. While it's true that moisture increases the risk of electrical shock, GFCIs can also protect against other types of electrical hazards, such as faulty wiring or damaged appliances. Another misconception is that GFCIs are a substitute for proper grounding. While GFCIs can provide protection in non-grounded circuits, They are not a replacement for a properly installed grounding system. A grounded system provides additional protection against surges and other electrical disturbances. It's important to have a clear understanding of the limitations of GFCIs and to ensure that your electrical system is properly grounded. Tenthly, let's talk about the importance of regular testing of ground fault circuit interrupters. GFCIs are designed to trip quickly in response to a current imbalance, but they can sometimes fail to operate properly due to age, wear, or other factors. To ensure that your GFCIs are working correctly, it's important to test them regularly. Most GFCIs have a test button that you can press to simulate a ground fault and verify that the device trips. It's recommended to test your GFCIs at least once a month. If a GFCI fails to trip when tested, it should be replaced immediately. 11thly, let's discuss the potential liability issues associated with failing to provide ground fault circuit interrupter protection in rental properties. As a landlord, you have a responsibility to provide a safe living environment for your tenants. This includes ensuring that the electrical system is properly maintained and that all necessary safety measures are in place. Failing to provide GFCI protection in areas where it is required can expose you to legal liability in the event of an electrical accident. If a tenant is injured due to a lack of GFCI protection, you could be held liable for their medical expenses, lost wages, and other damages. It's important to take your responsibilities as a landlord seriously and to ensure that your rental properties are in compliance with all applicable safety codes and regulations. In conclusion, installing outdoor ground fault circuit interrupter receptacles is a crucial safety measure that protects against electrical shock. Understanding their function, cost, and installation process can help you make informed decisions about electrical safety in your home or rental property. By prioritizing safety and taking the necessary steps to ensure proper GFCI protection, you can minimize the risk of electrical accidents and protect yourself and others from harm. Remember to consult with a qualified electrician for any electrical work to ensure that it is done safely and in compliance with all applicable codes and regulations.